Hello my dear students. Let us start our today's class with solution of assignment 8. First question is, a divergent lens of focal length 30 cm forms the image of an object of size 6 cm on the same side as the object at a distance of 15 cm from its optical center. Use lens formula to determine the distance of the object from the lens and the size of the image formed. So here given informations are the focal length of the divergent lens. Divergent means it is a concave lens, so focal length is equals to minus 30 cm. Height of the object h is always plus, it is plus 6 cm. And the distance of the image, that is V, is minus 15. Why minus 15? See the given information. The image formed on the same side as the object. So, this in front of the lens. So, V is minus 15 centimeter. Now, we have to derive the object distance, that is U, and the height of the image, that is H prime. So, using lens formula 1 by V minus 1 by U equals to 1 by F. Just transpose the term and substitute their value with their proper sign. See, V is minus 15 and F is minus 30. Just substitute them and calculate, and U we will get minus 30 centimeter. Clear? Now also magnification, from magnification formula, M is equals to H prime by H equals to V by U. Therefore, H prime equals to V by U into H. Now again we have to substitute the value of V, that is minus 15, value of U, that is minus 30, into H, that is 6. So just substituting and just calculate them, and H prime will be 3 centimeter. Means the height of the image is diminished here, and it is plus 3, means it is erect also. Now see students, I have to discuss one matter regarding your submission of from your assignment. So many of the students have submitted the assignment, and I have checked that your result is coming properly, means answer is okay, but in between the terms you are not using the sign properly. So still you are getting the correct answer, but if your steps and using of sign convention, if it is not correctly used, then you will not get marks. Clear? So be careful about the sign convention for lens or mirror numericals. See, we have discussed for last few days, we are continuously discussing only the numericals. As for your board exam, the numericals from lens or mirrors will definitely come, and most part will be from the numerical only. So be very careful about the sign convention for lens or mirror. Now our next problem, that is question number 2. Find power of a convex lens which forms a real and inverted image of magnification minus 1 of an object placed at a distance of 20 cm from its optical center. Now here the given informations are the object distance, that is minus 20 cm, as U is always negative, and the magnification M is equals to minus 1. And our target is to derive the power of the lens, means P equals to 1 by F. If we want to derive power, we have to derive first the focal length. Now see, for this kind of problem, while our target is to derive focal length, normally U and V are given, and from using them in lens formula we can derive the focal length. But here see, V is not given directly, but indirectly the value is given here. How? See, magnification here is minus 1. So using the formula of linear magnification, M equals to V by U, we can derive V. So just substitute the value of M and U, that is M equals to minus 1 and U equals to minus 2. What we will get? V is equals to 20 centimeter. Now next we will use value of V and U in length formula, and we will measure the value of focal length. So just substitute the value of V and U, and for F will be plus 10 centimeter. Clear? So as we already have derived focal length, now easily we can derive the power of the lens, and P is equals to 100 by F, as F is in centimeter. So P is 100 by 10, that is 10 diopter. Clear? Next we will discuss some questions answer related to lens. First the question is, 1/2 of a convex lens of focal length 10 cm is covered with a black paper. Can such a lens produce an image of a complete object placed at a distance of 30 cm from the lens? Draw a ray diagram to justify your answer. Now the answer is yes. The complete image of an object will be formed, but of less intensity. See here, we will get a complete image, but the intensity will be less, as the light falling on the covered portion will not reach at the image portion. Okay, and from lens formula, first we can derive the position of the image. Just see here, U is minus 30 centimeter, F is plus 10 centimeter. Using these values in lens formula, we can derive the distance of the image. And what we are getting here, V is equals to plus 15 centimeter. Means as F is 10 centimeter, V is 15, means it is in between F2 and twice F2. Now see, object is at 30 centimeter, means F is 10 centimeter, means twice F is 20 centimeter, means here the object is beyond twice F1. And we also know this, if object is beyond twice F1, image will be in between F2 and twice F2 on the other side of the lens, and the image will be real, inverted and diminished. See now how will be the ray diagram of such a situation I have given, you just check it. Now next question number 2. What is meant by power of a lens? Define its SI unit. Name the type of the lens whose power is positive. Now the answer will be, you have to write like this way. The ability of a lens to converge or diverge the ray of light after refraction is called power of the lens. And it is defined as the reciprocal of the focal length, that is P equals to 1 by F. And its SI unit is diopter. And what is the type of a lens whose power is positive? And the answer is, a convex lens has positive power. Now next question number 3. A doctor has prescribed a corrective lens of power 1.5 diopter. Find the focal length of the lens, and is the prescribed lens diverging or converging? Now see here, power P equals to plus 1.5 diopter. So if we want to measure the focal length in SI system, that is in meter, we will use the formula P equals to 1 by F. Or if we want to derive the focal length in centimeter, we will use the formula P equals to 100 by F. So here I am using P equals to 100 by F. So just substitute the value of P, that is plus 1.5. F we will get 66.66 centimeter. And as power is positive, focal length is also positive, means it is a convex lens, means the prescribed lens is converging lens. Clear? And finally, I am giving you one classwork for today. A convex lens can form a magnified erect as well as magnified converted image of an object placed in front of it. Now draw a ray diagram to justify this statement, stating the position of the object with respect to the lens in each case. Now here I am giving some hints to solve this problem. See, you just recall all the situation For two particular situation you will get magnified image, but one time the magnification will be positive and one time it will be negative. When m will be positive, means m is greater than 1 and positive, for that time image will be erect but virtual. And where the magnification will be greater than 1 but negative, the image will be inverted and real. Just recall the situation, and for both situation you have to draw the ray diagram also. Clear? Now this much for today's class. Thank you.